Hello friends, today we are going to learn the bisection method which is used to find the root of equation. Suppose we have one curve having equation f of x and this is the root of the equation. So we have to find the root of this equation by using the numerical method. So bisection method is the bracketing type of method. It's a bracketing type of method. So what do you mean by bracketing type of method? In case of bracketing method, we have to assume two initial guesses. Two initial guesses. That is x1 and x2. So selection of x1 and x2 is in such a way that the respective function of x1, that is f of x1, and the respective function of x2, that is f of x2. So the multiplication of this f of x1 and f of x2 should be less than 0. Should be less than 0. So one should be negative, one should be positive. In this manner, we have to select the f of x1 and f of x2. Suppose this is our root. So first initial case we are going to assume is x1 and suppose x2 here. So the respective function value f of x1, respective function value f of x2. By bisection method, it tells us that the next initial guess is x3 and that x3 will be x1 plus x2 by 2. x3 is x1 plus x2 by 2. So x3 is the midpoint of x1 and x2. So x3 is the midpoint of x1 and x2. So as per bisection method, x3 should be our root. But as you can see, x3 is not our root. x3 is somewhat far away from the root. So we are going to repeat the procedure. So respective function value f of x3. So for the next iteration, we are going to replace either x2 by x3 or x1 by x3. So to satisfy the convergence criteria is what? This is our convergence criteria. F of x1 and f of x2, the multiplication of these both should be less than 0. So we have to replace x1 and x2 by x3 to satisfy the convergence criteria. So the positive signs we cannot take because we need the less than 0. So one should be negative, one should be positive. So the same signs we are going to replace. So f of x3 is positive, f of x2 is positive. So replace x2 by x3. And for the next iteration, our x1 remains same. x1 remains same. x3 is replaced by x2 and this is our root. So to make the convenient calculation, I am just redrawing the curve. Now repeat the procedure. Respective function value new x2, respective function value new x1. So as per our procedure, x3 is what? x1 plus x2 by 2. So the midpoint of this is x3. So again, in this case, x3 is not our exact root. So we are going to replace the same procedure. So respective function value f of x3. So the same sign of x1 and x3. F of x1 is also negative, f of x3 is also negative. So we are going to replace x1 by x3, x1 by x3. So for the next iteration, x1 remains same, x1 remains same, but instead of x1 we are replacing x1 by x3. So we cannot take x1 here, we can take x3 and x2 as it is, and midpoint of this is x1 is replaced by x3, so this should be x1, this should be x2, and midpoint of this is x3. So if you repeat this procedure after some iterations, you will get exact answer as a x3. You will get x3 as a root for the multiple, from the multiple iterations you will get x3 as a root. So this is the bisection method. Thank you.